In this video, we'll be talking about kinematic equations. So I'm just going to give you a basic introduction to all of them and how to solve for kinematic equations. How to solve for systems using kinematic equations. So the first one, the most infamous one would be x of, so we have your final position is equal to your initial position plus your initial velocity times t. So t is time in seconds, and velocity is in meters per second, and x is in meters. Plus 1/2 acceleration times t squared. And acceleration is in meters per second squared. So meters per second squared. So this kinematic equation can be adjusted as so. So you can have delta x is equal to initial velocity times t plus 1/2 acceleration t squared. And the reason why you can do this is because if you subtract initial position from each side, you have your final position minus your initial position, and that all just equals your change in position. So final times initial equals change in position, and these two kinematic equations are the same thing. But usually you would use this kinematic equation when it comes to representing gravity, or you have some acceleration, and you have you have initial velocity, and you want to see how long it will take, or how much distance you have traveled. And let's see, you have this one now. You have the square of the final velocity is equal to the square of the initial velocity plus 2 times the acceleration of the change in position. And this is x of f minus x initial. You can also see this as the variable d, standing for distance. And this is another kinematic equation. We have another kinematic equation. This is another one. And keep in mind, all these are derivatives or integrals of each other. They all have some substitution going on, or any of that. But in the end, if you have all information such as acceleration, velocity, final velocity, and time, if you were to plug in all these values, you would get consistent answers with your previous equation answers. You have change in position is equal to initial velocity and final velocity over 2 times time. So these are the 4 main kinematic equations, and let's clear this up a little bit. So this is final position is equal to initial position plus final velocity times time plus 1/2 acceleration times t. Now here are some key notes here. You want to miss out variables. Don't miss out. So no missing variables. And what do I mean by that? Well, I just mean that whenever you're solving, or whenever you're picking one of these, so the hardest part is probably picking the kinematic equation that you're going to be using. That's going to be the hardest part. But whenever you're picking a kinematic equation, so picking kinematic equation, KE, kinetic energy. Whenever you're picking a kinematic equation, you don't want to be missing any of the variables. So if you're given acceleration and you're given initial velocity and time, and you're also given final velocity, you don't want to pick this equation here, because you have your acceleration. You want to take that into account. Hence the formulas. You can use the formula to take the acceleration into account. But if you're given all these variables and you don't pick an equation with acceleration in there, well, what's the goddamn point, right, of having that? And also another key thing that you want is to write down all the variables. So write down, as I said before, write down all information. That'll help you pick your kinematic equation super easily. So you have to write down all your variables that you have. So if you have acceleration, if you're given initial velocity, write down all the variables that you have, all in a list, rather than having in that word problem form that you're normally going to get for a physics problem. And another thing is, whenever you're using these, you can change it so you can solve for the final y position is equal to the final initial y position plus initial y velocity. So this would be initial comma so this stands for initial y velocity, plus 1/2 acceleration for y times t squared. And keep in mind this acceleration is just constant acceleration. All of these equations keep in mind constant acceleration. So all these have constant acceleration. And you also can solve for components individually. Solve for components individually. So you can solve for x and y by themselves. So this was just an introduction to the kinematic equations. And next video, I'm going to be moving forward to some practice problems with using kinematic equations. So if you want to watch that, it's going to be in my physics playlist. I hope this video helped. And if you have any questions, as always, put it down in the comment section.